a lot, and then we perform slicing and also subsetting of NumPy. So once you have a list of arrays, you can actually subset. So we also learn how to convert a 2D array into a 1D array using the dot flatten method. And you can also convert a 1D array to a 2D array by providing the shape that you want the 2D array to be, whether 3 by 4 or whichever way that you want your 2D array to be like. Okay, so with that said, today we are moving on to Numpy and Matplotlib. So previously we talked about Numpy and Matplotlib and how both Numpy and then both Numpy and then previously we talked about Matplotlib and list data structures, and we learned how to make some plots. So NumPy array or NumPy also can be used in plotting, because initially we said that just as we build that intuition or understanding that when you take any column of a data, you can consider that one to be a list. Likewise, when you take that same column of data, you can consider that column of data to be a NumPy. However, the advantage of NumPy is that you can take numerous data and it is efficient when it comes to performing calculations. As such, NumPy becomes a useful tool when you want to visualize data. Let's say you want to learn about the relationship between two columns or the distribution of values within a particular column of data. You can use NumPy, because apparently when you have data in a tabular form, which we call the pandas, the columns that are in the pandas are a representation of NumPy arrays. Okay. All right, so with this, as we learned earlier, before you to install them, and after installing them, you need to import them into your working directory or to the ones are true. This one cannot be printed, okay, or else there will be some error. So it just to tell you that your libraries are loaded. So once they are loaded, we can use them. Now let's see that in action. So line plot. So the line plot helps us, create to create a line plot between two values to learn about trends. We saw that in when we're talking about lists. So in this case, let's take this code for instance. So here we say that months equals to np.arange 1,13. So we know about this one that this is the same as the range function that we use in lists. So this is going to create a list of NumPy arrays from 1 to 12, right? And it said that revenue equals to NumPy.array. So here we pass on a list into the NumPy.array function. And once you pass a list as an argument to the NumPy.array function, it converts that list into a NumPy array. So now Python does not see that particular list again as a normal list, but a NumPy array. And then here too we have month labels. So in the month labels, we've created a list of the month. Okay, so here we did not assign it to, we did not convert it into NumPy arrays, because NumPy is used for numerical Python and numerical data analysis. So once we are done, then we are going to do our plotting. So in this case, we have to create our figure, which is like the board, and then the axis, which is the axis. Okay, so plot.subplot, and then we create the size of the figure. Okay, so we say that axis, so plot. So with the axis, plot month labels for your x-axis, which would be these ones, and then the revenue here for your y-axis, and then you color the line still blue. The thickness of the line should be 2. The marker, as in the data point on the line, should be O, and then the marker size should be 6. That should be how big the size should be. And then we set the title, we set the X label, that is the description of the x-axis, and then the y label, description of the y-axis, and then we ax.gray to true. That's you. So when we run this code, and the tight plt.tight layout actually prevents the 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 labels from being hidden. Okay, so without the tight layout, there could be a tendency whereby the labels will be hidden. So here you can see that we have a chart whereby we have the month on the x-axis and then the revenue on the y-axis. And in this case, we have a plot of how the revenue of the company actually changes over a period of time. So we started from January, February, March, and then up to, so from here we can say that in January, from January to February, it decreased, but from February to March, it increased, then it decreased a bit, then kind of. So it helps you to interpret the data more brilliantly other than using the numbers. All right, so that has to do with the line plot. So we want to add a computed mean line to it. So in this case, we say that figure.ax equals to then the same. We specify the size of the board or the size of the figure. Then we say ax.plot. Then we say the month labels, the same thing. Okay. Then once we are done, we see that monthly mean equals to revenue.mean. This revenue.mean actually creates calculates for the mean of the revenue, which is this one. So once the mean of the revenue is being calculated, then we can now use that one to create we can use it to create a horizontal line. So to show us that this is the mean. So we use the ax.axh line. Then we specify what should the value of the line be. So the y value will be equals to what? The mean, which is this. Okay, then we want to color the line red, and the line style should be dashed lines. And then the line width should be 1.5. That is how bold the line should be 1.5. And then we want to label it annual average, and then we want to pass on this average mean here as the annual average to 0. So we don't want any decimal, so we are returning it as a whole number using this particular expression. So once we are done, we set our title label, and then we set our Y label, and then our legend. So the legend is the text that tells us that this color belongs to this, that color of the chart belongs to that. And then we use our grade in order to help interpreting the chart more easily. Tight layout to make sure that all the items fit on the page. So when we run this code, okay, so we are going to see that the average revenue is around, it's just close to the 16,000, okay? So by this, we can see that from January to May, the company was performing below its average, its mean or its average revenue. However, in the month of June, it increased above the average, and then in July, it decreased below the average. However, when you look at this particular chart and you want to use the mean to calculate, it's very difficult. But once you bring this particular line, the horizontal line, using this particular expression, all that you can see is that here, the mean line will be drawn for you to easily differentiate between what was higher than the average and what was not higher than the average. Okay, so here the legend is what created these ones. So in this case, the legend, that function that we passed over here created, so it tells you that the line represents the monthly revenue, and then the red dashed lines represent the annual average, which is equivalent to 15,375. That is what we did over here. So you see that there was no decimals over here, because apparently when you calculate for the mean, you will get some decimal, but we use that .0f to convert it to a whole number. So we are saying that no decimal, but if this place is to be 1, that it will move to a 1 decimal place value. So it's that it is 0.0 because we moved this one to the 1. All right. Okay, so that is that for another one. So here you can see that we are using a NumPy array and therefore a list of months. So NumPy array and then the list of months. Okay. Array and therefore a list of months. So NumPy array and then the list of months. Okay. All right, so let's make progress. So comparing two simulated time series. So in this case, maybe we have two different products and maybe we want to check their revenue over the 12 months period. So here we set a random seed 42 to get a reproducible random values. So we say that visit equals np.a range. So generate numbers from 1 to 12. And then we say that, okay, so the BP underscore patient equals to np.array. So this, we pass a list into the NumPy array to make it a NumPy array. So and that represents the BP or the blood pressure of the first patient, or patient A. And then the patient B, we also use the NumPy.random to generate a list of values for the BP of the second patient. And in this case, we are using the NumPy.random, sorry, dot normal. So the random dot normal, that means that this one represents the mean, and the scale is the standard deviation, and the number of values that we want to return is 12. Okay, so in this case, you will see that the values that will be generated will be centered around the mean with a standard deviation of 4. So we say that BP equals to np.run BP patient B, so dot as type integer. So in this case, we are converting the values that will be generated here to an integer. And to do that in NumPy, you just use the dot as type to convert every item here to an integer. Okay, so with that said, we set the normal BP to 120 and then the high BP to 140 to create thresholds. Once we are done setting our parameters or the values that we'll use for the chart, then we'll come to the actual chart. So always we create the figure and then the axis using the plt.subplot, and then we specify the figure size based on the dimension of the graph that we want to plot. Okay, so in this case, we say that ax.plot, I mean that's in the axis.plot. So here the x-axis should be the visits. Okay, so the visits will be 1 to 12. And then the y-axis should be the BP of patient 1. This is patient A. Then we are giving it the color coral, and then the line width 2, and so on and so forth. And for the second plot, so we are plotting two graphs on the same, two charts on the same graph board. So here the x.plot visit. So we are using the same visits as the x-axis, but in this case, the y-axis, we are using the BP for the second patient, that is patient B. We specify the color, the line width, the marker size. We want it to be square, so we specify it with S. And then the marker size should be 6, and then the label should be patient B. Once we are done, we want to make the threshold for each of them. So the threshold one is x.x horizontal line. So create a horizontal line. And what is the threshold? So y equals to the high BP, which is this high BP over here. So you specify the color, the line style, and then the line width, as in how bold the line should be, and the label that you should give to it. So the label should be hypertension threshold. And then we provide this hypertension threshold, which is the 140 as a threshold. And then it says that the x.h line, that y equals to the normal BP, which is this one. Okay. And then we specify the color, the line style, and then the line width, and then we label it. Okay. Once we are done, we set the title for our graph, and then we set the x-axis label for the x-axis, and then the label for the y-axis, and then we set okay, and then we also set the so the x-axis as in the visits. So when I plot the graph, I will show you that one. And then we set the legend. So always this legend will acquire the labels over here. Okay, the labels over here, and then their color. So it will tell you that this particular line, this is the label, and this particular line, that is the label. Okay, so that is what it does. So each and every time you are specifying your parameters for your plot or for your X, H line or V line, you need to provide a label for it so that that label will be acquired by your legend to tell people who are reading your chart that this particular line belongs to this one and that particular line belongs to the other line. So let me run it and then let's see. Okay. All right. So here you can see that we have how do we call it? We have our y-axis, sorry, y-axis and then the x-axis. So in this case, the number of visits spans from 1, 2, 3, 4, 5, 6, 7. So we want to check like the rationale behind this graph is to ascertain the blood pressure level of 2 patients over 12 clinic visits. So on day one, this patient, which is patient A, so by the legend, we know that the coral one, the plot with the coral color is for patient A, and the plot with the blue color is for patient B. And then the hyphenated dashes is for the hypertension threshold, which is the 140. And then the normal limit is the 120. So we use those ones with dotted lines. Now, in this case, we can read the data that on day one, as both of them visited the hospital, the patient A has the blood pressure of patient A was extremely high, even above the hypertension threshold. Okay, around between 155 and then 160. However, for the patient B, his own was around between 135 and then 140. So it would be like 175 thereabout, or 136. So it would be 137 or 136 thereabout. But however, provided maybe they were being given some medication, we can say that based on this data, patient A responded much more positively to the drug than patient B, because though patient B's blood pressure wasn't so high, it looks like his own did not decrease so drastically, because it just, the beginning was around 136, but however his blood pressure ended around 132 or 133 or 134 thereabouts. So the difference is not so much. So with this, maybe if it is 2 drugs that we give to the people, we can see that maybe this person respond positively to the drug than this, which will also create a new research question that, okay, why is it that this patient B did not respond to the drug as compared to patient A? So that can be a new research field where we can seek to explore. Maybe it could be that maybe the genetic makeup of the person influenced the drug that he or she was giving to. Or maybe the person was doing something that contributed to the rise of his blood pressure. Because when you look at this, see that over time, over the number of times the person visits the clinic, his blood pressure always decreased. So it decreased alongside. Please, you get it.